Hey, welcome to all these examples to summarize VSEPR shapes. Let's get right to work. So, first off, do we have lone electrons around the central atom? We've got no. Some Lewis dot structures, we could have things like hydrogen bonded and HCl. And even something like oxygen double bonded to carbon, double bonded to sulfur with all of its valence electrons. So Lewis dot structures have to have all the valence electrons. 3D shapes, not at all. We represent a pair of electrons bonded with a straight line. So you've probably seen these throughout your time. And oxygen double bonded to a carbon, double bonded to sulfur. So each of these are some 3D shapes of linear modeling. As far as bent, do they have lone electrons? Yep, they do. Some examples of Lewis structures are your familiar water, or you could also have something a little more complicated. But when it comes to the 3D structures, we need to show these actually bent at an angle. So the idea is that this is showing water, and our nitrogen, we could maybe have a straight pair here, but we'd have an angle for this hydrogen as well. So this is showing that it is angular or bent. Trigonal planar. Nope. No lone electrons around that central atom. This is where things get a little more complicated. Again, this would be something that you would have done for your Lewis structures like we practiced. Just giving you some examples. Boron is an exception to where it happens to be fine with its 6 electrons instead of 8. But the way we would draw these is showing that it's making a triangular molecule, but we show them all in the same plane. Carbon with its double bonded oxygen, and again you can see at an angle, hydrogen, angle, fluorine. We'll come back to if these things are polar or not momentarily. Trigonal pyramidal, yes, Rybovsky. It's got lone electrons around the central atom. Ammonia, a very common one that's utilized. And something a little more complicated with phosphorus in the middle as the central atom. Maybe with a fluorine needing its valence electrons. So this is where we're going to use the diagrams with the different structures here. So for nitrogen, I like demonstrating we have 2 coming towards you, kind of like 2 legs of a tripod, and then these dashed lines behind. So I think of it as a tripod, to where 2 are coming towards you, 1's going away. Same for this phosphorus model here. And dashed lines. And so let's have a fluorine, a hydrogen, and a hydrogen. Lastly, tetrahedral, no unshared pairs. We've got our pretty common methane. And one up here. And a little bit change to that. Maybe a Cl somewhere. And let's do these ones here. So with the methane, we have this pair that is in the same plane. So we can use a straight line. While these down here we need to use the kind of tripod feature of two coming towards you, one going behind. So H up top, coming towards you, coming towards you. And again, we've got an H, a CL, and another H. Now let's look at if these things are polar or nonpolar. So based upon the shape, some are always going to be polar. Every single molecule that's bent or trigonal pyramidal is always going to be polar. The other three, it's conditional. If we have different elements, different atoms without symmetry, polar, same atom around the central atom, nonpolar. So same atom, so nonpolar. Different atom, polar. Different atom around the central atom, polar. Here we have different atoms around the central atom. Here we have the same atoms around the central atom. The same, so nonpolar. We have something different, so it's polar. So this kind of guide should help give you an idea of polarity of the molecule, which will help you understand what kind of physical properties it will have. So that becomes very important as we move forward. Let's look at our final thoughts. What does a teary, joyful Santa say about chemistry? Ho, ho, ho. Be sure to answer the final question and come in with any kind of questions you've got. Take care.